Have you ever pondered the marvels of human evolution and the boundaries of reproduction? Imagine a world where the conventional norms of gestation are challenged, where science ventures into uncharted territories. Today, we invite you to embark on a journey that transcends the limits of traditional childbirth. Join us as we delve into the cutting-edge realm of artificial womb technology, a groundbreaking innovation that redefines the very essence of nurturing life. Prepare to be amazed as we unravel the mysteries and discoveries encapsulated with this transformative domain.
The evolution of medical technology has reached a transformative threshold, unveiling the prospect of creating an artificial womb. This invention, driven by developments in a number of areas such as ex vivo uterus models and in vitro fertilization, represents a paradigm shift in reproduction. At its core, an artificial womb extends far beyond addressing reproductive challenges. It embodies multifaceted implications that redefine our comprehension of gestation.
Artificial wombs, capable of nurturing and sustaining the growth of the fetus outside the human body, holds promise as a beacon of hope for women facing uterine complications. Moreover, they present a revolutionary solution to mitigate the staggering mortality and morbidity rates of preterm infants, marking a significant stride in neonatal care.
Artificial womb technology offers a novel approach to traditional neonatal intensive care unit treatments, which often lead to complications such as infections, heart problems, and lung damage. It does this by stimulating the natural womb, but could be done with more control and regulation. This could minimize risks and improve overall outcomes for preterm infants by potentially reducing the stressors and complications associated with premature birth.
Yet, the significance of these artificial environments transcends immediate reproductive hurdles. They redefine our understanding of gestation, nurturing embryos from their earliest stage to viability and beyond, offering profound insights into embryonic growth and gestational dynamics.
Still, relevant concerns are raised regarding these artificial settings' suitability for physiology and development. Problems with stimulating complex interactions between a mother and a fetus that are essential to embryonic development continue to arise, requiring a great deal of research and ethical considerations. In addition, the shift from animal research to human trials raises questions about how well technology will adapt to human physiology and its hazards.
With this information presented, the primary objective of this synthesis paper is to consolidate and analyze a spectrum of research findings, emphasizing the profound implications of artificial womb technology for embryonic development. It specifically seeks to address the question, does artificial womb technology have an adverse impact on the developmental trajectory of embryonic body systems? This analysis will intricately explore the physiological, biochemical, and morphological milestones achieved during gestation within these innovative systems. Furthermore, this analysis aims to scrutinize potential future directions for research and implementation, evaluating the hurdles and opportunities inherent in refining and integrating artificial womb technology into clinical practice. By comprehensively elucidating the nuances of artificial womb technology and its profound impacts on embryonic development, this synthesis endeavors to play a pivotal role in shaping the trajectory of research, clinical implications, and ethical considerations surrounding the transformative domain of ectogenesis in human reproduction.
In order to create a thorough overview of how artificial wombs actually impact the complex developmental processes of developing embryos, this presentation will address a variety of topics pertaining to this technology. First, we'll be looking through the current advancements in artificial womb technology. Next is the developmental implications of AWT, wherein we explore how it influences embryonic and fetal development. And lastly, the challenges and limitations associated with AWT.
Let's start by reviewing the variety of artificial womb technologies that have been developed to support the growth of lamb and pig embryos. Biobag technology is used for both lamb and pig embryos, while ex vivo uterine environment is utilized for lamb embryos. First in the list is the UAUV biobag system designed by Partridge and others in 2017. This system includes an umbilical vascular interface, a closed fluid exchange environment, and a pumpless arteriovenous circuit that resembles the fundamental elements of placental circulation. In this technique, water and nutrients are continuously delivered through the cannulae, and fetal heart works in conjunction with oxygenator to regulate blood flow. It is noteworthy that even though this technology has successfully maintained 100% of preterm love fetuses, which are comparable to just viable human preterms, 6 out of 8 had had complications during delivery.
Another cutting-edge medical technique is called ex vivo uterine environment or EVE therapy, which involves using an artificial placenta to give nutrients and extracorporeal gas exchange to a fetus submerged in heated amniotic fluid. 5 Merino cross Iwis participated in this investigation. After surgery, the fetuses were born, attached to an artificial placenta, and immersed in a bath of amniotic fluid.
But what is this EVE therapy technology? Membrane oxygenators, inflow tubes, and outflow tubes make up this kind of technology. Additionally, a bath of amniotic fluid is included in the system. However, the results of such technology have shown only a limited fetal survival, with only 27 hours as the mean survival time. Moreover, lung maturation for the fetus was also non-existent.
On the other hand, because pigs' fetuses are similar to premature human infants, artificial placenta technology has been adapted for piglets. This device allowed the fetus to be nurtured in an artificial uterine environment by using a pediatric hollow fiber membrane oxygenator that was connected to the fetal circulation via the extra-abdominal umbilical veins. Though capable of supporting the piglet, this kind of technology has demonstrated shortcomings in supplying a typical fetal physiology.
The development of embryonic body systems is adversely affected by the use of artificial womb technology, as demonstrated by these 3 distinct technologies. Furthermore, the outcomes of the various artificial womb systems indicate that the technology's viability is limited to a particular period of time or threshold.
Now that we have tackled the 3 different developments in artificial womb technology, let's now dive into the developmental implications of artificial womb technology.
The examiner researchers provide substantial evidence in favor of the main hypothesis, which holds that the development of embryonic body systems is negatively affected by artificial womb technology. All of the technologies under investigation improve the chances of survival for preterm fetuses, but there is a major downside. There is an increase in developmental complications, which calls for a comprehensive analysis of its dual effect. The repercussions might be minor or severe and include things like altered physiological parameters, abnormalities in development, and heightened susceptibility to certain illnesses. However, it is crucial to remember that the approaches used in the researches under discussion differ particularly in its composition, wherein one might have included artificial vascular interfaces or oxygenators. Because of this complex interaction, artificial womb technology is currently under critical review with a focus on the need for continued study, technological advancement, and ethical considerations in order to maximize its potential and minimize any negative impacts on fetal development.
However, there are certain limitations to this paper that should be recognized and taken into account, such as the limited available resources, ethical considerations, and the fast pacing of fetal development.
The study acknowledges its shortcomings, which are mostly the result of the lack of scientific literature on artificial womb technology because ethical issues have received so much attention. The difficulty of keeping ahead of the quickly changing field of AWT is acknowledged in the study. The study highlights the need for future research to prioritize a more equitable distribution of resources, encouraging collaboration across interdisciplinary fields for a comprehensive exploration of AWT despite these limitations. It also emphasizes the significance of striking a compromise between scientific advancement and ethical issues.
Now that we have discussed and analyzed all the pertinent information about artificial womb technology, let's now go back to our main question. Does artificial womb technology have an adverse impact on the developmental trajectory of embryonic body systems? Artificial womb technology highlights a complex environment with both potential benefits and innate difficulties. While the reported 100% survival rate among test subjects is an impressive accomplishment, the concurrent appearance of intricacies and unanticipated difficulties warrants prudence when it comes to the quick translation of AWT into human clinical trials. For this reason, fetus development remains to be negatively impacted by artificial womb technologies. Moreover, the moral implications of this technical developments demands that we proceed cautiously until the problems revolving it is thoroughly addressed and minimized. And that is the end of our presentation about the effect of artificial womb technology in the development of the embryo. We hope that as this presentation ends, you learned a thing or two about this new emerging technology in the field of developmental biology, which aims to transform the traditional NICU treatments. Additionally, please scan the QR code found at the side to be able to read more about this paper. Again, thank you for listening.